So we're going to go to a panel discussion and Q&A. I'm going to get to Q&A first, but I want to make sure, just to start, by asking the non-speaking panelists, if you could explain in maybe 1 or 2 minutes, kind of what your firm does in the big picture and how that fits into serving industrial customers like that. So maybe we could start with Ben Burke from Dispel. Could you give us just 1 or 2 minutes so people understand your role in this space?
Yeah, so my name is Ben from Dispel. I don't need to say anything, so I won't, but I think the most important part is partnership. It's being able to take customer requirements and work with them. Because when we showed up, it was not perfect, and it was mostly a trust built between ourselves and their team that allowed us to work through issues, get to what the pain point was immediately, and then work on that, and come back and say, does this actually work for you?
Okay, Ron?
Sure. My name is Ron Victor. I'm the founder and CEO of IoTium. We provide converged infrastructure as a managed service for our customers like Rexnord. Basically, let the domain experts focus on the domain, leave the plumbing and the infrastructure to us. And the plumbing and the infrastructure does 3 things. It allows you to securely transport data from any brownfield asset to an application in a data center or a cloud. It allows you to push applications to the edge in containers, so you can now run any application you like at the edge: encryption, compression, dedupe, DPI, machine learning, AI, whatever you like. And the third thing it does is manages third-party remote access into the asset to go in and change set points. That's what we do.
Okay, thank you very much. And Ted Masters, I presume that a lot of people are familiar, but if you would just give us a 1 or 2...
10 minute?
No, 1 or 2 minutes. But I'd also like to know if you can squeeze into that 1 or 2 minutes kind of a little bit of future direction, because it would seem like you're a little disconnected from this space at present, but not in the future that's not going to be true. So go right ahead.
That's right. Well, it's a little on the mechanical side, and I'm Ted Masters, by the way, CEO of Philcom Group, and we're a standards organization. We play mainly in the process automation side, but the Rexnord example is really a pretty good analogy to what's going on and how standards organizations can help on the process side. The gearbox is more or less a mechanical system in a box, and we deal a lot of times with process systems in a box. So we'll have maybe a skid-mounted process in a box, and we help through standards make things in that box work really well. We talked about availability and uptime. We work primarily between the control system and the sensors in that box to make sure that they're precise, the values are right, they're not out of calibration, the diagnostics, they're not about to fail, things of that nature. So we create standards around the communication of all that data and information from the devices into the control system. And then the other point of how we can improve through standards the efficiency of what's going on in that box is really with the data. I thought it was a very good point that just throwing a bunch of data up just creates a tremendous mess. But you want the actionable intelligence out of that data. So you've got to get the data in a standard way. You've got to get a standard set of data, regardless of the equipment coming in. I need a standard set of data. I need to see that data in context, and I need to see it in an information model that different machines and analytics and applications can compare it and can run models against it and things like that. So if you don't have the data in a standard way, you've got throwing up a bunch of data, and you can't derive the actionable intelligence out of it. So that's another thing standards do in terms of the IoT. They essentially take all that data from the field devices, integrate it together, and put it up in a standard way so that you can derive intelligence out of it. So that's a pretty good analogy for the box. And then my last 30 seconds kind of on the process side. Process isn't really like that. There is no box. You've got all kinds of suppliers and devices and types of things that need to communicate in a standard way to the systems in the plant, to be integrated together and to roll up into common information models. So that's primarily the process world that we deal with. And then finally, the standards can help in interfacing that box with the real world. You can have a self-contained box with its own smarts and its own intelligence, but you may want to also, in a standard way, interface that data to a broader enterprise picture of everything going on in the plant or many other boxes. So we look for standard technologies to do that.
Okay, thank you very much. I'd like to turn to Q&A now. I have questions, but I think your questions are better necessarily. So please, if you have a question, now's a good time. Somebody should volunteer. Nobody's, there we go. There's a question right there. And you can direct your question to the whole panel, but I prefer if you have somebody in particular you'd want to talk to or ask.
We have somebody in particular.
Okay.
My question is for Mr. Morse.
Just because I gave you a flat tire?
Yes, I've been very upset about that this whole time.
I apologize. You may want to introduce yourself.
Oh, I'm sorry. My name is Joseph Mon. I work for Mitsubishi Electric. I have a question for you. I'm interested in how you, because I'm assuming that you provide the monitoring as a service to your customers. I'm interested in how you're selling this. I'm sure it's pretty clear or pretty easy to imagine for a very high dollar value item. But for the lower cost items that might be in a critical application, how is it that you introduce the concept to your customers, and how do you do it? Because I'm assuming that they might come back at you with something along the lines of, well, you're telling us that your product's going to fail. So how do you? That's what I wanted to ask about.
Being a mechanical company,
Sorry about
or
that.
is this not on?
Oh, I don't know. It wasn't, just me, yeah.
Being a mechanical company, we face the issue that all of our stuff will fail. So we're very upfront with that at the beginning. It may be years, it may be decades before it does, but it will. What we are trying to get across is more this aspect of, we're going to help you in improving your rigor and discipline around how you do maintenance for it, reducing the cost of that maintenance, because you should only have to do it when you need it, and improving the effectiveness of that maintenance so that when you do need it, you have all the right stuff and you have the right spare parts, equipment, have the factory direct replacement parts and things like that. So the conversations have gone interesting ways, depending on what level of maturity of the company. Like I say, some folks are still at break fix, and the conversation there needs to actually be elevated to a level to where somebody is writing a check at a corporate level to say, I actually do want to improve my productivity on my maintenance schedule. And just going to a scheduled maintenance or a predictive maintenance kind of regime, I don't know how to do that. I don't have the right equipment. I don't have the right mechanisms. Can you help me with that? So it's engaging them in that journey and how they do maintenance more than it is around the particular failure modes of the product itself.
Okay, other questions from the floor?
Okay, I have a question. I'm Paul
Okay,
Kuch with Monster.
sure.
My question would be directed to Ron. Ron, what type of edge devices do you run on today for both aggregating that information and having that right-hand rule, three-way communication that was described for Rexnord?
The the actual edge substrate or hardware is dependent on each application. RIC will need a different edge substrate, a locomotive vendor needs a different edge substrate, a power plant vendor needs a different edge substrate. So we're agnostic to the edge. The way we choose the edge is the following. First qualifier is what interface do you need? Because you're talking to some legacy machine or a new machine, so you might need CAN bus, Modbus, RS-232, or OBD2, or serial, or two-wire, so, or Ethernet if you're lucky. So that's the first thing. The second is how much edge compute are you going to run on it? And my advice to everybody in this space who's ever looking at this is, please buy the most amount of CPU and memory possible, because the cost of rip and replacing that device because you ran out of juice is going to be $5,000 by the time you do a truck roll, send somebody there, rip and replace it. Notice that when you buy a laptop, you never buy a laptop of last year's. You always buy a laptop which is about to come out next month, so that you have future-proofed yourself. So that's the memory and compute. The third thing is hardening. What kind of environmental hardening do you need? Vibration, temperatures, etc. The last thing is tamper-proof modules. Do you want to be absolutely secure with tamper-proof modules built in, or are you okay without a tamper-proof module? All of these considerations, we sit with each customer on which use case they're doing, and that defines the edge substrate. And there are certain cases where the edge does not need to be a hardware. It could be, if you have VMware or OpenStack running in a plant, we will reside as a VM at the edge too. It's rare, but it's coming. When you look at 5G in manufacturing, the 5G MEC, the mobile edge compute that's going to sit in the plant talking to a 5G sensor, will be just a blade server running us as a virtual machine.
Okay, there's a question in the back.
So this would be a question for either William or Ben. You mentioned, William, about the dynamism of IP addresses. Can you speak to a little bit about why dynamic IPs versus static IPs has been a benefit for you?
So if you think about it, with a static IP, they know they can tell where you're at, right? You can look up that static IP host name, whatever, right? And they know they can attack that specific IP address. I see it every day in our firewalls. As opposed to dynamic IP, it's like a moving target defense. They're not going to know that IP itself. And by the time they've already pinpointed that, you close that, another one comes up. So if you think about it, it's hard to hit a moving target, right? So if you think about moving target defense, that's why it's better to have dynamic IP spaces, or able to open those spaces up at will, as opposed to having a static IP address.
And I guess I would add to that. Earlier on in the presentations, there was talk about how cloud computing kind of comes to the edge and where it can be used in some of these networks. So we integrate with all of the major public cloud providers. So one benefit to that is you can pick where you want to deploy resources, whether it's way overseas or right next door. It's a lot easier to deploy those resources. Also, from a IT perspective, deploying systems that have been automatically patched is a far better process to have than having a guy come in and do it himself.
Okay, there's a question in the back. Mr. Bartusiak.
Hey guys, good morning. Don Bartusiak with ExxonMobil Research and Engineering. Hey, this is a comment and an opinion. I think we need to define terms on edge devices, and let me give you some data. So, Rick, in your architecture, I mean, a computer sitting above the DCS or PLCs, I mean, we wouldn't call that an edge device. I mean, we have thousands of computers sitting above DCS's PLCs today. I wouldn't call them edge devices at all. I mean, Ron, your comments about, I forget what you called it, edge, strata, substrate. I mean, I think we need to build on that. I mean, and really define terms here in terms of what we're talking about. Because if I think of the world that Ted's coming from, and we actually, have technology, individual sensors with modest amounts of compute capability at the single point, ultimate field device level. So I think really for us to make some headway as an engineering community, we probably need to do a better job at defining terms, which will then help us better define requirements and standards. So again, it's not really a question. I invite comments, but I think we'll do us all a favor if we do a better job at defining terms on what the edge actually is and what its requirements are. Just a comment.
I completely agree, because to your comment, you are envisioning our Rexnord edge as actually above the PLC. I would say it's below because the way it communicates is only as a slave up on Profinet or Modbus TCP or Ethernet IP. So you're absolutely right in that we're creating a whole infrastructure of new devices, and part of the thing I would advise everybody do is think about the problem that you're trying to solve, create the right thing. Don't be locked into the IT architecture of what they think IoT is. Come up with the device that is required, that solves the right problem, and I'll join you on this band of we don't have the right nomenclature for some of these things. People call my thing an edge. I call it a doohickey or a widget, but it does some things like an edge because it does this, but I don't know any other edges that do that.
I would like to ask the suppliers maybe to comment on that, Ron and Ben. If you could maybe, a question for the end users is asking about this terminology. Can you reference us to some areas or dictionaries or something like that that you would recommend, or what would you say about that in terms of getting a terminology? Because it is difficult. I dodged the question at the beginning for that very reason.
Right, and you're absolutely right. There are, in my world, when I deal with this, I always say there are multiple edges. There's no single edge. And then I'll give you the analogy of this in a very simple manner. If you have looked at 5G even slightly, you're going to have a 5G sensor with some compute on it that's sitting on a machine. Now, that became the edge. But that's going to talk to a 5G gateway sitting inside the plant, which is going to consume all the sensor data and run some intelligence. That also is the edge. That's going to communicate to a 5G server sitting at a tower, which is taking multiple data points from all of this and computing even more. And that's also the edge, and then running up all the way to a central office. And then the data center. So how many edges do you have? And I think in our world, whenever somebody will talk to IoTium, you will always come across a term that we had to invent for this thing, and we call it the TAN, the Thing Area Network. We say that is the thing, that is not the edge. The Thing Area Network talks to the edge, and from the edge goes upward. But then from the edge, we go to a super edge. What is a super edge? It's a consolidation of edges that came to. So you have to call, node, super node, mega node, all that good stuff. But is there a dictionary? Not yet that I can point you to, but happy to work with you on trying to come up with one.
We need another, maybe a 10-layer Purdue model that gets down into.
We've had enough trouble with 5 layers. Ben, did you have a comment on that?
I mean, the comment that I mostly have is that there's a definite disconnect between the OT teams and the IT teams. So at least making sure that you're creating relationships where you can explain across that edge what somebody means, because the edge to the IT person is very different. It's, well, I put you in the right space. Can you actually do your job? And the OT person is saying, no, you put me in the wrong place and I'm not touching the right things anymore. So there is a definite disconnect there, but I feel like you have a lot to say about what standard dictionary should be built for this kind of terminology, perhaps.
Okay, it's good comment, and one that maybe we should wrestle with. I'll take that as feedback that ARC should probably wrestle with that in some sense in the industrial and automation space. Other questions? Be careful, if you don't ask one, I'm going to, so it's a warning. Yeah, I don't ask that hard a question. But okay, I will go ask one, and this is more to the end users. Rick, you talked about the speed of machines and actions that have to take place at the speed of machines, and then you said there's other actions that take place at the speed of money, which is much more relaxed. But you also make a lot of metal products that have long lives, and so I think maybe there's a longer speed called the speed of design, which maybe doesn't change too much, or it may change, but the concepts probably last for a long time in your products. William, you've got utility infrastructure like that also is extremely long-lived. So I wonder if especially Rick, because you're working with these products, can you give us some insight into how you enable these products in terms of internally you have to get intelligence added to these products, and that involves some kind of design change to the product. So did you learn anything by working with your product people to modify those designs that facilitated that, where you're taking an unintelligent device and adding intelligence to it? Can you tell us a little bit about that
Sure.
process and what you learned from it?
There's probably one key learning that I think is dancing around there. To physically mount some of these sensors, you've got to typically do some sort of at least another set of drawings of something to where you've got some tap holes or something added to it to make that change. In the speed to be able to get to market, you may choose to go after a geometry that is bigger than you would desire. And so you have to make some trade-off as to how much are you going to change. Let's take a pillow block. I don't know if you know what a pillow block is. It was that big casting that has a bearing in the middle of it, and the pillow block is bolted down to the floor or ground of some kind, holds that bearing in place so it only spins this way. That casting was designed for our roller bearing family probably 15 years ago and has not changed. Now, we can update it to drill a couple of holes in it, to put some sensors in it, to attach the wires, wireless, all those kinds of things to make that happen. To optimize that for the best possible, we should actually make a new casting. But that costs literally millions of dollars to make new casting designs for 14 different bearing sizes and things like that. So there's a crossover of adoption that we want to get to before we actually do the redesign of that, because I know that the device that I'm going to go to market with this year is probably twice the size of what I want to get to before I redesign the casting. And so we've got some aspect of, I can do some things right now just with drilling some holes on the existing design and keep the existing design. The gearboxes have the same sort of deals. We've drilled into the races around the bearings to put RTDs in and things like that. And we've not had to modify the actual design, but for the two older ones that still have 20 and 30 years of life out there, but we've come out with the one that came out of the box with the V-Class has all of that actually designed into the original housing. So there's places to put the sensors. So those are trade-offs that you have to think about and say, well, do I go after, because I know one of my competitors actually redesigned their castings for a product, and they had a huge flat on the casting that they designed to, and they've just introduced a new version of that sensor, and it's a small fraction of the size of the space that they created on that product, that they didn't need to really do the full redesign of this monster flat.
That's an interesting answer. I appreciate it. And kind of an aside area, but it's still very, very interesting struggle.
It's a moving space. So commit, get into it, do some things, but understand that it is a moving space and try to take that into account. Take that into account into how you set up the infrastructure, how you containerize, how you make it modular to go forward, future-proof it, and good decisions on where you spend capital for the mechanical issues.
Thank you very much. Other questions? Oh, there's one. Mr. Sirico.
Hi, I'm Paul Sirico with the Fieldcom Group. So this question is really kind of directed at Rick. I loved your flat tire example, and it's a great example. You've got some units, you got bar, you got PSI, you've got some ranges. But then you bring up the point that you need some. You don't want to get that information. You want to know the tire's about to blow up or the tire's low, and that implies a lot of abstraction of information and then a lot of business logic being applied to that. Do you feel that there are enough tools available and enough standardization available to make those types of actions an easy action, or is there more work that needs to be done?
In general, I would say there's not any standardization, and the mechanisms for creating that business logic, we've had to hand build.
Sir? Other questions? Still waiting? Okay, well, I'm going to say I think we should owe the speakers and panel a round of applause, and thank you very much.